This is CPM Calculus, Chapter 3, number 138. So for each graph below, do two things. Trace f of x onto your paper, and then write the slope statement for f of x. Sketch the graph of f prime of x using a different color. Okay. So I don't really have to sketch it because I already have it here, right? So I just want to write the slope statement for f of x. Well, this is a line here, right? F of x is just a line. It's going down, 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 down at a constant slope, right? A line has a constant slope. Well, let's go ahead. If this is 1, 2, 3, and 4, and 1, 2, 3, and 4 in the y direction, well, what is the slope of this? Well, I can look here and see, right? I'm just looking at the slope. I'm seeing that the change in y, the slope of this line is equal to change in y over change in x, right? And I see that it goes down to -2 in how many x values? 1, 2, 3, 4. In 4 x values, or -1/2, okay? So since our line has a constant slope, so we're doing part I, right? The slope statement, f prime of x, is just going to be that constant slope, right? Is equal to -1/2. All right? Again, you could also think about it as if f of x is equal to this line, it's going to be equal to -1/2 x plus 4, right? It's basically y equals mx plus b. The y-intercept is here at 4. It's going down 1 over 2, down 1 over 2, down 1 over 2. So this is f of x. So f prime of x is going to be using the power rule. This is going to become 0. This one just becomes -1/2. Okay? So this is part I. So part 2 is sketch the graph of f prime of x. Okay? So sketch, I'm going to use green. Sketch f prime of x. Okay? So this is 1, over here is -1, right? F prime of x is just -1/2. So it's going to be here at -1/2, and it's going to be -1/2 always. So down here at -1/2, this is f prime of x, right? Here in green, f prime of x is equal to -1/2, right? So everywhere, for every x value, f prime of x is -1/2. All right. Let's go on to the second graph here. So here we're asking again to write a slope statement for f of x. So this is f of x, right? And what does f of x look like? Well, it looks like a sinusoid, right? So we're doing part I. F of x is just a sinusoid. It actually looks like it's a sinusoid shifted up. But let's pretend our axis, let me just draw our axis. If our axis was right here, right, then this would be cosine of x, right? But instead of being here, it's shifted up, right? This is basically cosine of x shifted up by 1, 2, oops, what did I do? This is basically cosine of x here. Well, let me just draw cosine of x. Right? It's basically shifted up 1, 2 point something. So we could write that as, let me just fix this, plus, I don't know, 2.2, right? This is just cosine of x shifted up. So the slope statement then, f prime of x, is going to be, well, what's the slope statement? What's the derivative of cosine? Is negative sine of x, right? Plus 2.2, well, we no longer, that's x to 0, so the power rule makes it plus 0. And we don't even need to write that. Okay? Another way you could look at this is, well, what are these? These are the max and min. So let's go on to let's just go on to part 2, right? Sketch. So I'm going to sketch based on the graph here. I'm looking at the maximum and minimums. That's my zeros. Concave up. Well, it's concave up to the right at this point, right? So that means we are going to be increasing. And from here to here, it's decreasing. So that means we're negative. So we're going to be it's going to be increasing here and negative. Concave down means it's decreasing. So from here to here, it's going to be decreasing, right? The point of inflection, right, is where we have, interesting enough, we have a maximum or a minimum. Here's a minimum, right? To the right of this point, it's increasing and concave up. So that means it's positive and increasing, right? So it's going to be like this. Over here, it's increasing and it's concave down, so that means it's decreasing and positive, so something like this, okay? And as you can see, this looks like sine of x, right? Sine of 0 is 0, and it goes, well, it looks like negative sine of x, because sine of x would have been going up and down like this, so it does look like negative sine of x, okay? And that's the sketch, and this is the slope statement right here. Okay? Let's go on to part C. Part C, so what is f of x? So let's do part 1, part I. F of x, this is a parabola. The parent function is x squared, right? And x squared is over here, right? And looks like this. But this one's reflected, right? And then shifted up 3 and right 3, right? So this one's just x squared reflected, shifted up 3 and right 3. So how would we write that function? What we would do is it would be negative, right? That's reflected. Shifted up 3 means we're going to add 3 outside the parentheses. Right 3 means we're going to subtract 3 inside the parentheses. So this is the function of f of x. F prime of x then is going to be, drop the 2, it's going to be negative 2x minus 3 to the power of 1. We don't need to write that. Plus 0, we also don't need to write that. Okay, so this is the slope function. We could distribute the negative 2. We get negative 2x plus 6, right? Here's our slope function. Okay? Sketching it. So first sketching it, I'm going to just look at the graph, and here's the maximum, so I know right away that that is a 0, right? To the right of the maximum, it's decreasing, so that means it's negative, right? It's also concave down, so that means it's decreasing, right? This whole thing's concave down, so it's always decreasing. And over here, it's increasing, so that means it's positive. So it's going to look something like this, right? But it has to pass that point. And also, we know exactly what it looks like. The y-intercept is 6, so we go up 2 more. So this is 4, 5, 6. So this is the y-intercept. And it goes down 2 over 1. Because the slope here is negative 2 over 1. So it goes, rises down 2 over 1, down 2 over 1, down 2 over 1. See how we hit our point? So this connects to these points and keeps going. And put arrows on it because it's a line. And that is the sketch, okay? So now we can go from approximate sketches to exact sketches, right? Because we know the parent functions and we also know transformations from them, so we can get the exact equation, or pretty exact, and also the sketch, okay? So this is the end of CPM Calculus Chapter 3, number 138.